So let's keep talking about scaling your apps in the cloud. How many of you are actually running application developers running your apps in the cloud? How many of you are sysadmins? Okay. What is the rest of the group then? Let's see. How many of you are managers who know nothing about cloud and are here for education? Okay, so the rest of you are at OSCON because... Speak up, I won't bite. DevOps operator. Did you raise your hand when I said sysadmin, or were you insulted by, I'm not a sysadmin? Yeah, no, right, exactly. You're too good for sysadmin. All right, so the whole point of this is about talking about from a developer perspective, okay? But that feeds into DevOps and sysadmin because in the new peaceful world where lions lay down with lambs, these two groups should be working together to really build a successful app. So the agenda is learn a little bit about platform as a service, although probably not, and then a little scaling, and that's it, because I only have 30 minutes. So the assumptions is I present some of what we know, and then we discuss. Like, I really want this to be a discussion session. It's a small enough session, and these areas are new enough where I would like to actually get feedback from people in the cloud and then get a healthy debate going, because I'm going to bring up a term. I'm going to prep you for it now, so you can ignore the rest of my talk and just get the arguments in your head ready. Microservices. Does that, like, stir debate among anybody here? Anybody excited about that? Nobody. Yes, thank you. I saw your hand go up, so I'm going to call on you when we get to it. That's it. So scaling, I was trying to think of what a great scaling picture would be, and I couldn't really think of one, but I thought this was a great picture in the end, because scaling is like when the Twitter fail whale, do you remember that when they had problems with scaling? Plus also it's kind of like Moby Dick coming up under your boat and taking you out when something really big hits you and you haven't built for web scale. That was on the fly analogy. So there's two types of scaling. The first is vertical, which is bigger, stronger, faster. Okay, so camera guy, I just want to say though, where did the camera, he left the room. It's going to be hard for speakers to walk back and forth this way because there's like all an obstacle course. It's like American Ninja right here. Bigger, stronger, faster. And then horizontal scaling is swarm baby swarm, right? So this is the example of vertical scaling, right? The traffic is the skinny little white boy, right? And you got some sort of scaling event happening, and what you do is you build something bigger, stronger, faster to overwhelm the traffic. Add more RAM, you add a SAN, you start adding all sorts of really fun stuff. I need a bigger server, right? And I'm looking at the average age in this room is somewhere about mine or older. So most of you are used to this version of scaling, right? When traffic used to come in, you'd call the ops team and you say, buy more servers now, or I need a bigger server, or throw more RAM in it, right? Is that right? Okay, thank you. That was a lukewarm at best. But yes, that's what most of us did, and that's how most of us learned to build our applications, right? You build one big Java app or one big PHP app, and then if you were good at scaling, you'd put your database server on another server, right? So you'd have an app server and a database server, and you didn't put them on the same machine, so you had independence. And that was your, I'm web scale. This is vertical scale, horizontal scaling, right? It's the idea like a swarm of ants. So that when something big comes in and you need to handle it, you just start throwing replaceable things. Isn't there no such thing as irreplaceable? No, irreplaceable really means it's irregardless. That's the not real word. You just keep throwing ants at it, right? Small little ants to carry that large ant, that large spider. Not one ant by itself can carry the spider, but you keep throwing a bunch, and if one gets bitten by the spider, it's not a big deal, because there's a whole bunch more ants around to pick up the load, right? So why did this take so long for us to get to this? The first part is we needed cheap commodity hardware. And I would say that is cheap, easy to buy commodity hardware that wasn't like out of the back of your Linux magazine, right, where you could assemble your own server. But like, we needed cheap commodity hardware. And I think this was actually, we needed Moore's Law to catch up. I think this is actually the biggest reason we didn't have vertical scaling. Moore's Law in the broad sense. What? Hardware? Yeah, I don't know why. Well, because cloud, virtual, I think is why I put that. Thanks for catching something I didn't think too much about. And then there's ease of creation and deletion. So this is where like the people like Chef and Puppet and all the other DevOps people come in, is the ease of creating and deleting servers. I remember when we used to ask for servers, it would take weeks, and then to provision a server would take a very long time. And that's just, you can't do that if you're going to horizontally scale. And then after those two things are in place, you can start to build software that grows sideways. Right? And I think that was the big paradigm shift that happened for a lot of people. Rather than I'm going to build it bigger and look for optimizations in my tight loops, instead you're going to say, I'm going to look for ways that I can just keep adding servers in, and it's going to grow across the side. So this is kind of a propaganda talk. Now I'm going to have to move out of the camera, but it's not propaganda at all, actually. I'm only putting this up as the way most people scale. This is how we scale at OpenShift, but don't pay attention to the particular words. The idea is this could be infrastructure as a service. Does everybody know what infrastructure as a service is? And the difference between platform as a service and infrastructure as a service? If you don't shake your head saying yes, that means I will have to explain it. So does everybody understand the difference between platform as a service and infrastructure as a service? No, thank you. Infrastructure as a service is Amazon, is OpenStack, it's CloudStack, right? You get virtual machines on the fly, but then it's your job to do what you want with those servers. Nothing else is provision. Platform as a service is Cloud Foundry, OpenShift, Heroku, where you say, I want this stack, provision it all for me, and then you'll spin up more of the application tier as I need it. I never touch networking or anything else. Is that good enough? Okay. So that same model, though, applies whether it's platform as a service or as infrastructure as a service. You basically partition up a bunch of stuff, and then you have something that handles spinning up more stuff, right? And so here, we can actually spin across here, which is the same thing you would have to build yourself in infrastructure as a service. And I'm not saying one is better or worse. But what I'm saying is you basically start breaking your things up into different tiers. Your load balancer's on one tier, your application stuff's in a different tier, and it can scale independently, and it's built to scale independently, and your database is on another tier. Okay, so this gets us to, since I have 23 minutes left, I'm going to have to slow down then, because we're going to run out of time. This gets us to, I think, where we are today, which is microservices. Right? So does everybody know what microservices is? No? Okay, how many of you know about SOA? Does everybody in the room know what SOA stands for? Service-oriented architecture, right? So service-oriented architecture, big JEE thing. It basically, and I should say .NET as well. It was basically web services with a capital W and the capital S, right? And the idea there was you were sending XML back and forth with all sorts of complicated protocols, but you had this thing called a service bus in the middle, and that would coordinate all the transactions between all the different pieces. And then what came after web services with the capital W and the capital S? What was the next big thing that was actually built for humans that handles that same kind of stuff? REST. Thank you. See, that wasn't that hard. And good job. See, I'll give you positive reinforcement if you take a risk. REST was the thing that came out to replace, for humans, web services with a capital W, like WS star. Right? And so what this starts to enable is us to start to use the web to build those same kind of service-oriented architectures without all the, I need to spend $60 million on Oracle training and WebSphere and all that other stuff and have all these, I need 7 levels of enterprise architects figuring out how all that's going to work together. And so microservices, I think the term was coined by Fowler, but I don't know for sure. It's the next evolution of SOA. They did a very bad job of not acknowledging that SOA was kind of its roots. It is the roots of it, but it's just done more at a human scale. And so the idea with microservices is, this was your typical old school application, right? Everything's bundled together, it's one huge monolithic app, and when you need to scale it, you need to scale up the whole application over and over again, which is quite complicated and can be quite expensive, because if this purple thing that's the limiting factor, and everything else is underloaded, you're actually scaling up a whole bunch of other stuff that you don't actually need, right? That's old school SOA with single monolithic applications. Microservices, since you raised your hand before in the back, who's the poster child for microservices? Who? Docker? No, who's the poster company that's used microservices in production? Thank you, who said that? Thank you, in the back. Netflix is the poster child for microservices, right? So the idea with microservices is, who's another one that there's been a lot of write-up about lately, and it's one of my favorite music services that I'll evangelize even though I don't work for them. Yes, Spotify. Right? So Spotify organizes like this. Teams belong to each one of these. Right? The team is not this. The team is this. There's another team for this, and there's another team for this. And those pieces release independently on their own schedules and on their own servers. So even within one company, this could be Node, this could be Java, and this could be Java. And the database team, you could have 3 different kinds of databases. It's whatever the team needs. And what they do is they communicate across using REST, and they communicate usually with an event manager, like a message queue, right? Instead of some service-oriented architecture bus. And so this is what Spotify does. They have teams that work like that, and they release each piece independently. And then they don't say there's no specific hardware requirement for what that has to run on. It can run on any pieces of whatever the DevOps sysadmins spin up, right? And they work with the DevOps and sysadmin. Notice, look, see? Nothing's the same on any of these boxes. There's complete independence. This ant gets taken out. I can spin up the pieces of the ant anywhere else I want to. I don't have to say, oh, right, that's on that specialized HPU, no offense, HP, but that HPUX or AIX software, and it only runs on there. Or you could even say it even spins on RHEL. I'll pick on myself for a bit. It has to be on that RHEL box with the following configuration. It's no, there is a box, that is our box, we have 3 sizes of those boxes, and then I'm going to have to spin this up on a large, or I'm going to have to spin this up on a small. Right? And so that's what gets us to scaling in the cloud. There's some advantages to this, and I'm going to ask you to start naming what some of the advantages are, because everybody's about to fall asleep, and we're only in the first session. So what could you see as some advantages to this architecture? You want me to start? Go. Good. Yes. Right. It's object-oriented at the sysadmin level, or the systems level. You've decoupled everything, right? You just agree on an interface, which is your, I'm going to send you this URL, you're going to give me back this JSON. And that's all you have to agree on. And as long as that's agreed on, it's totally decoupled. I don't have to sit here and worry what the release schedule of the red, if I'm on the yellow team and I need to talk to the red one, I don't have to worry about their release schedule. I don't have to time my release schedule with them. Right? My release schedule becomes my release schedule, their release schedule is their release schedule, as long as everybody obeys the same contract, which is object-oriented in libraries, right? So it's taking a good concept and building it up. But you can also think about that when I come to the bad parts. You already answered one, so I'm going to try to get some more crowd participation. What's another advantage? Yes? Exactly. So the team gets to pick what they think is the best technology for their part of the stack. Right? So if I'm in charge of the part which is publishing a bunch of data out really quickly, I don't want you to come to me and say, you've got to build that in JEE. Right? I want Node. And I want to be able to hire Node developers because I want to be doing real async right off the bat. All my JBoss partners are going to get really upset with me that I just said that. But still, if the new cool kids who are doing async stuff want to do it with Node and Mongo. Right? And so you can hire Node and Mongo developers without having to have a complete stack. You do have to build a team, though. But yeah, next. That's right. So because I'm supposed to repeat everything. You said it very nicely, but because we're recording, I have to kind of say it again. You get encapsulation. This app, if I bring in some library, like let's say we're now back in Java. What are most of you programming? PHP? Java? Or run Java in your shops? Are there any other languages out there? That's so funny. Ruby? Python? Okay. So this guy's install a Python dependency, right? And they install a different version that collides with this group back in here. What happens? Yeah, you're screwed, and you have a month of everybody arguing with each other about which is the version they're going to use and why can't we do this. And then this group says, oh my gosh, but we had this dependency particularly on that really old version. You're going to have to, I think all the speakers are going to move this way, dude. No, there's like an obstacle course over there. Okay. So, but over here, I can install whichever Python dependency I want, and I don't care. My team has to decide, but it's only my team, right? So there's a lot less configuration where we're yelling at each other about who gets to have what version. I mean, if you're dealing at the infrastructure as a service level, this could be Ubuntu. This could be Red Hat. This could be .NET, right? It's not even at the library level. You get encapsulation even for the operating system level. And some would argue, and this is where I take off my microservices preaching hat, because I don't really necessarily agree with this, is that these should all have their own databases. Right? I think sometimes there is value in having them share a database. You lose some of the encapsulation because you're talking to the same data source. But sometimes it makes sense to have, if this is a user management system and this is a reward system, I kind of don't want to maintain 2 sets of users. So I would want them talking to the same database. Maybe. Okay. We've got some really good reasons why and does everybody that does infrastructure as a service also, at the systems level, see why this is a good idea? Some of you sysadmins, I'm expecting you to say something at some point. Yeah, look up, because you got to, a sysadmin looking at you in your email, or you're looking at Zabbix. I'm sorry, you're monitoring your systems and making sure they're staying up. What are some good reasons for sysadmins about this? About going to this horizontal scaling? Yeah. Yeah, efficiency and cost. You can pick this one to be, let's say this is that node server. You can do this one with like 512 megs of RAM, right? This is the Java server. You're going to do that one with like 8 gigs of RAM, right? So you don't have to, with this one has 64 gigs of RAM because it has to support everything. And you only have to spin up as many of these as you need for that piece, right? Yeah. That's right. So I bet if I were to talk to, so he said that it simplifies monitoring because you're monitoring a simpler set of things. I bet if we were to talk to the Spotify sysadmins, or maybe they actually said it in the article and I didn't see it, I bet they have sysadmins assigned to each application, right? So if you have a bunch of, because one of the things I remember with sysadmins that they hated about developers bringing in new technology is if this is 4 different technologies in here, their monitoring team, the whole team, has to know all 4 different technologies at once. And when things go wrong, you're having to figure all 4 of those out. Here, if I'm the sysadmins assigned to the, or DevOps people assigned to the user application, I just have to know the code that's in the user application. And if it's Node, then I only have to know how to run Node and run Node at its best. Yeah?
How is failover affected by this microservices?
So failover, I think failover becomes, usually what's happening inside here is there's event buses to talk in between them, right? So you talk across an event bus. So you send messages out onto the event bus, and whoever's able to answer can answer, which is better than in this case where it's all tightly bound inside. It's also easier to scale up. If you start to see that, or to handle failover, if these 2 die, all I have to do is spin up 2 more of these. I don't have to spin up 2 more of these just to get those 2 little boxes right there.
If I'm thinking about disaster recovery,
Yeah.
I'm going to need to think about each one of those as a service that needs to be provided on an emergency basis if something happens.
Right, so his point is that if in an emergency recovery, you need to start, instead of thinking of this, you need to think of this, and then you need to think of this, and then you need to think of this. You're going to have to come up with a plan for each one of those. Yes, I agree. You'd have to have more granular plans. But some would argue that's actually easier than trying to think about, in certain ways, than this. What's some of the drawbacks now, since I'm now down to 12 minutes? Yeah. Yeah. I would agree with you about that. So his point is security, or things which are overarching across all of your suites of applications, are harder to think about and harder to architect, right? Hold on one sec. So I've been trying to build a microservice myself now. Like, I'm actually trying to really live the pain rather than just eat the stuff and say, oh my gosh, this Kool-Aid is so good, you should drink some. And that is one of the first things I ran into. Like, how do you handle authenticate? Like, so the user authenticates against the app up here. How does this app, this app, this app, this app, and this app all know that that user is authenticated and allowed to access that service? As opposed to here, that's right. You'd have to, but then you also have to get into token exchanges, and you have to get into OAuth and stuff like. You have to get at some level, which is more complicated than here, right? If I did it here, I would just tell the app server to have domain level authentication, then I can just boop, it's there for me. Right? So there are pieces that you have to give up. Like application-wide services are much more, they take more thought to be built right rather than relying on your app server or whatever you're using to give you that out of the box. Right? That's one of the drawbacks. Coordinated large-scale things are more difficult and chances for you to screw up. That's right. So the other one was you have to pay more attention to the wire. Right? The network actually starts to matter a lot more.
Specifically, you end up with far less north-south and more east-west traffic between the services.
Yeah.
And traditionally, we've architected networks so that we're pushing out to the consumer, and everything that we're communicating is internal to the box, right?
Right. So yeah, this is, so the point was, since they can't hear on the video, is traditionally, we've architected for things, networks for this, not for this, right? And in here, this is all this, and just one pipe this way, probably at some application sitting up out here. And the other thing, what does that mean? Like back in our days when we were building apps, what was told to us was the most expensive thing? Sorry? Round trips. Yeah. So back in the day, one of the reasons you didn't do scalable by putting your database server on another machine was you were told it is expensive to leave your machine and go to the database machine and then wait for that to come back. Right? So there are certain use cases where this makes more sense. If I really care about the time it takes for the data, like at microsecond level, response from the database, this is not going to be the most efficient, nor help me meet my goals. Right? Because there's going to be at least a couple round trips probably to get anything done. So that's one of the drawbacks of microservices. Yeah?
Well, you said, as you were explaining it, that you thought that there should be databases for each app.
Yeah.
That was a good design.
No, I don't necessarily think that's always a good... No. So microservice, Rastafarians are ones who think like REST has to be exactly like the thesis, right? Where it has to obey that whole entire structure. I don't believe that about REST either. I think that REST, I use it more of a pragmatic perspective. And from this, I'm actually more pragmatic about this either. I think it's kind of silly to say everything has to have its own database. But that would help with latency, because I might not be talking as many hops, but I actually think that freaks me out. I'm not ready to take that leap yet. All your data. Yeah. Yeah.
I think you brought up the point that developer teams are easier to hire, but I'd like to bring up the point in microservices, you have to have a much, much more talented sort of architect or team lead that really understands this stuff. And those guys or gals are in limited supply. There's a real manpower problem when people put things like this up and have them actually work.
So yeah, that's the early adopter problem that you're going to run into if you try to do this right now, right? Almost all of us, for the last however many years, have been taught to do this. And if you go and hire an architect at this point, most of them are going to know how to do this. And if you go and hire sysadmins, for the most part, they're going to know how to do this. And most developers are going to know how to do this, right? And so I think getting human people, well, all humans are people, getting people, I was trying to avoid the word resource. Right? Because what does that mean? What if you refer to your people as resources, they get to refer to you as overhead? Isn't that what right? So I'm not using the word resource. But then I couldn't think fast enough about, I'm still a bit jet lagged from flying around a lot. It's harder to find good staff that can do that now. Right? So I think some of it is going to be actually you taking the burden on yourself and training up your staff. Right? Like do some small test projects. There's a bunch of great articles out there about people talking about taking their monolithic, like there's a really good one about taking a monolithic Ruby application, right, and then walking through all the steps to get to this. And it doesn't show much Ruby code, so I was not that uncomfortable with it. Yeah? Yeah. No, I think so. You're saying the same. He's talking at the gentleman in the black shirt, or is it blue? Black, because it's NSA, right? He's talking at a higher level. So I think I agree with you that if hiring at this level is much easier. Hiring at somebody who can see this picture and manage that entire picture, much harder. Because there's not as many people out there who've done this and have done it well. So you have to try to poach people from like Netflix and Google, and good luck with that. Right, because that's hard to poach unless you're a good startup. Yeah. Right. So the high school student in the crowd said you can always hire high school students. He has his resume in the back corner after my talk is done. So yes, you could also take 40-something-year-old guys and gals and teach them as well. But let's not get into a debate about hiring high school students right now. That is a great idea, and I'll leave it at that. It has both its pluses and minuses. Yeah. Yeah, so that was one of the, so he said making the scope of the microservice, determining what's the actual scope of the microservice can be challenging. And that's one of the things I got into in architecting my app. Like, how fine-grained did I want the service to be? Right? Like, do I want one service that's just for reading users and another service that's just for writing users? Like, should those be completely different services? Or do I have a user service? Is that too much? So like, some people, so we have an internal list at Red Hat called Core, which is all of our Java devs. If you want to talk about a flame war. So we have everybody on our team that are from like total microservices people to people who like born, bred, will die making applications this way. And the arguments back and forth were like, some people were like, they were making fun of the fact that was so micro, right? Some people were like, it's like the same as having one object. It should only have one file. Each microservice should correspond to one file, and that's it. And I was like, no way, that's dumb. So there's a lot. That's part of the reason why I'm bringing this up. I want people to read about this and think about this more. That's the main reason I brought this up. Because it's a new area. I think at the app tier, you're going to hear stuff about all sorts of other stuff today. What I try to talk about today is what's come in the cloud is now we do horizontal scaling, right? That, if you want to be a successful, if you want to, oh nice, Sarah gives an intro and then ditches. So if you want to do what Sarah was talking about that compute model where I can take my app and plug it in here and plug it in there, you can do this, but I would argue this is much more complicated to be able to get to that pluggable model, right? Microservices and horizontal scaling is what's going to get you there. How many of you actually do horizontal scaling in your organization today? Right, so how many of you do vertical scaling in your application today? See, I loved asking those questions because then it shows all the people who don't raise their hands. You all get C's in the class. Everybody else who raised their hand, you get an A. I think this is what most people have to start thinking about. And my recommendation for it, whether it's microservices or some microservices light or some sort of idea like that, if you're greenfield, I would say go for this from the start if you want to be in the pluggable compute model, where you want to be able to switch out easily. Because what you could do, this could be running on Amazon, this could be running on Azure, this could be running on Google, depending on who gave you the best performance, right? There's nothing in that model that says those all have to be on the same cloud. But you're buying latency into the whole model no matter what, right? So someone yelled out latency. This is building for a latent world. I agree. So you might say like, okay, this one's in Amazon. This is some back-end processing engine though, where we do our extracts and that's not in Amazon. That's in Azure because I can get better compute pricing there.
I don't buy the data center location argument because we already have to do that. It's not like I can slap my stuff on an East Coast Amazon server and have it available on the West Coast. The time difference for people on the West Coast accessing that is huge. You got to put them all over the place anyway.
Yeah. Okay, there you go. He said it better than me.
I mean between your components, not between the users. Well, I understand that, but we actually have servers that access databases that are across the country. So it's effectively the same thing. You have to put this stuff all over so that you minimize the impact on the end user. And it's really going to depend on the type of app.
Okay, so I'm going to wrap up with a minute and 20. And I'm going to go through these fast because I really wanted the debate and I wanted people thinking about like starting to move towards that kind of service model. That was my main goal. Avoid sessions. So for those people who are in the big old app server model, you're like, I love sessions. My Oracle cluster or my JBoss cluster, they make sessions for me easy. Sessions are the death of horizontal scalability. Loosely couple your pieces. We already talked about that. Message bus, something else in the middle. Design for retries and small pieces failing. And I think this is the thing that's also different between that big consolidated model. In that big consolidated model, you assume everything in your big box is always up. And if something goes down in any part of that big box, you're like, the whole thing shit the bed, I need to reboot the whole thing. In the horizontal scaling model, I assume that will go down. That's why you see Netflix building like Chaos Monkey. How many of you have heard of Chaos Monkey? Right? That's where they basically introduce something to rip apart their network and their services to see how well it stands up. So build with that in mind. Use the architecture of the web for you. Don't work against it. Capital W web services was not web friendly. REST services are. Use the verbs. Use the things that make the web fast. And caching is your friend. I should probably start with that one from the beginning. So that's part of that whole database discussion. Cache the bejesus out of anything you can cache. Okay? Got your picture? Okay. Moving on. Last chance. Okay. Let's wrap it up. If cloud, then architect that from the beginning. Right? If you know you're going to be in Amazon or you're going to be using your own OpenStack or CloudStack, architect your apps that way from the beginning if you can. These patterns get you more flexibility, resilience, and capacity. Oh, I'm out of time. SLAs don't help when your app is down. I wish people would frickin' get off the whole SLA thing. It doesn't SLAs really don't matter. What you want to know is how well they respond and how well they bring things up. Them guaranteeing 5 nines, if they only give you 3 and then they give you like $10 back because that's how much it actually costs to run your service, that means nothing. So stop thinking about SLAs and think about how you can build your app around the SLA. And I'm done. Thanks.